Hi everybody, you are welcome to this video lecture session. I am Atanubetal and in this video I am discussing about how to write electronic configuration, what is electronic configuration and what are the principles that are required to write the electronic configuration. All points I like to clear in this video. And first of all, for electronic configuration writing we can follow the two system. One is the cell conception, cell system, another is subcell system. What is cell? Cell is the part of an atom where electron revolves around the nucleus, and cell is named as K cell, next cell is named as L cell, and for K cell n equal to 1, L equal for L cell the n equal to value is 2. So for each cell, what is the maximum number of electrons that are accommodating in a cell? This can be calculated by using 2n square formula. For the L cell, the number of maximum electron that it can accommodate is 2 into 1 square for K cell. For L cell, this is 2 into 2 square, that means 4, 8 electrons, and here it is 2 electron. So maximum number of electrons that can accommodate in the L cell is 8. So similarly we can calculate M cell. In M cell, what are the maximum number of electrons that can accommodate in the M cell, and in this by following this formula, the maximum number of electrons that can accommodate in K cell, L cell and M cell, we can write the electronic configuration of any element. Suppose for sodium, it has the atomic number 11 and we write the electronic configuration as 2, 8, 1, because it is in K cell. K cell is fully filled. 2 electron is the maximum capacity, so it is fully filled. Next, the out of 11 electron, 8 electron will fill in the L cell, and after completing L cell, electrons start to fill in the M cell. So in this way we can write electronic configuration of element by using cell concept, cell system. Similarly, we can take another one example. It is 12 magnesium, atomic number 12. So we can write electronic configuration 2, 8, 2. It is K cell, it is present, 8 electrons are present in L cell and 2 electrons are present in M cell. So this is the process of writing electronic configuration by cell system. In the cell system, KLMN, the number of electron distributed according to the capacity of each cell. Next point is the subcell concepts. What is subcell? Subcell is the division of the cell into subcell. Subcell is the division of the cell. Subdivision of the cells is called subcell, and subcell consists of a number of orbitals. So by using subcell concepts, we can write electronic configuration following ways. See, we can write electronic configuration using 1s2, 2s2, 2p6, 3s2, 3p6. In this way we can write electronic configuration of an element, or we can write electronic configuration of the element by orbital diagram process. As for example, this is called electron spin, 1s2, 2s2 and 2p6. So in this way we also can write the electronic configuration, or we can write electronic configuration using a inert gas, argon, then 3s2, 3p6, etc. In this way we can write electronic configuration. Here the spin, it is the up spin or positive spin, and this is down spin, it is negative spin. Down spin always a negative spin. Okay, so before writing the electronic configuration in the subcell system, we have to understand few principles and few rules. So first point that we need to understand, what is subcell and orbitals. Orbitals and subcell and the accommodation of electrons in the orbital and subcell. A subcell consists of a few orbitals. For example, 2s subcell has only 2s orbital, it has no more orbital, it has one orbital only. For 2p subcell, 2p subcell, it has 3 orbital, one is 2px, another is 2py, and another is 2pz. For 3d, for 3d subcell, we have 5 3dxy, 3dyz, 3dzx, 3d x square minus y square, and 3d z square. We have 5 orbitals are present in the 3d subcell. So each subcell, these are called subcells, and each subcells, these are called orbitals. Orbitals that are present in the subcell. 2s orbital, it is written as this one, 2s. So subcell and the orbitals. 2p subcell orbitals are 2x, 2px, 2py, and 2pz. These are the orbitals present in the particular subcell. Now we have to understand the maximum number of electron present in a subcell. For s orbital, the maximum number of electrons is 2. For p orbital, the maximum number of electron is 6, and for d orbital, the maximum number of electron 10, and for f orbital, the maximum number of electrons that it can accommodate be 14. So these are the maximum electron capacity that an orbital have, that a subcell have. An orbital always have 2 electron capacity. Whatever it is, orbital always contain 2 electrons. It cannot contain more than 2 electrons. Orbital always have 2 electrons. Next important point is, so electronic configuration means the distribution of electron in the atomic orbitals. So during the distribution of electron in the atomic orbitals, there are some principles and rules that we have to know. First principle that we have to know, it is Aufbau principle, and according to this principle, we know that this principle, according to this principle, the electrons are arranged in the orbitals, this is the orbitals. Orbitals are arranged according to 1s, 2s, 2p, 3s, 3p, 4s, etc. This is increasing order of n plus l value. N plus l value increasing order, the orbitals are arranged in increasing order of n plus l value, and the energy of the orbital, the energy of the orbital, orbitals are increased. This is the increasing order of orbital energy, increasing order of energy of orbital. So we distribute the electron for a particular element in this order. At first electron will come in 1s orbital, then electron will come 2s orbital. After completing the maximum capacity of 2s orbital, the electron will next come to the 2p orbital. After completing the total capacity of p orbital, that is 6, electron next come to the s orbital, and after completing the total capacity of s orbital, electron comes to the 3p orbital. This is in according to Aufbau principle. Here we check the n plus l. N here is 1, s is 0. So n plus l value is 1. Here 2 plus 1 means 2 plus 0. 2 plus 0 means it is n plus l value is 2, and here n plus l value 2 plus p means l equal to 1, 3. So this is the n plus l value, n plus l value, n plus l, n plus l, n plus l value increasing in this following arrangement. So these orbitals are increasing in energy and increasing in n plus l value, and this is according to Aufbau principle. We have to know the second principle, that is the Paulies exclusion principle. According to Pauli said that no 2 electron have all the 4 quantum numbers same value. That means for 2 electrons, all 4 quantum numbers cannot be same. One quantum number value should be different. For example, take we are taking electron number 1 E1, the values of quantum number n equal to 1, L equal to 0, n equal to m equal to 0 and s equal to plus half. It is for the electron number 1, and for the electron number 2 the set of quantum numbers would be 1, 0, m0 and s should be minus half. That means all 4 quantum number values are not same for 2 electrons. One quantum number values are different for 2 electrons. This is in according to Paulies exclusion principle. And in block diagram, when we will write the electronic configuration, we have to take care that for 1s2, for writing 1s2 we can, this is a right configuration, but for 1s2 if we write electronic configuration using this, means both are up spin, this is a wrong one because it violates the Paulies exclusion principle. Paulies exclusion principle said that one quantum number value must be different for 2 electrons, so this one is violating Paulies exclusion principle. So before writing electronic configuration we have to always keep in mind that our electronic configuration is allowing Paulies exclusion principle allowing our electronic configuration, otherwise our electronic configuration becoming a wrong configuration. So next we have to understand for the case of 2p for 2p no this one, suppose this one is violating Paulies exclusion principle because both spin are in the same direction. Another important rule that we have to know, that is the Hunds rule. According to Hunds rule of spin multiplicity, that when electron filling starts in atomic orbital, electrons are filled up at first singly, and after completing the all orbital singly, the electron gets repeated. As for example, we are discussing this point, okay, it has another case, okay. Now we are discussing about Hunds rule. Hunds rule said that suppose it is 2px, 2py and 2pz orbital. At first 111 electron comes in the 3 orbital. After completing this 3 orbital by 111 electron starts repeating. So this is in according to Hunds rule. Here look at this figure. Here Hunds rule is not obeying because one electron is the first order of arrangement. Here we are seeing that 2 electrons are accommodating in the same orbital, so it is violating the Hunds rule. And it also violates the Aufbau principle because Aufbau principle said that 2 spins cannot be in the same direction. So it is violating Aufbau principle and Hunds rule both. This is right, this is the right one. It is not violating Aufbau principle, not violating Hunds rule. So according to Hunds rule, this one is not valid. This one is right. So we have to keep in mind that our electronic configuration is in order our electronic configuration following the all rules and principles that are required for fulfilling. So these 3 important principles and rules are very important for writing electronic configuration. One is Paulies exclusion principle, another is Aufbau principle, and another is Hunds rule. Now we are now we start to write electronic configuration of some element, because we already know the points that are required to write electronic configuration. Now we start to write electronic configuration of some elements. As for example, we are writing electronic configuration of carbon. Carbon has atomic number 6. Its electronic configuration is 1s2, 2s2 and 2p6. sorry, it is 2p2, 6, total number of electrons 6, 2 to 4 and plus 2, total is 6. Or we can write this electronic configuration using orbital diagram by 1s2 and by 2s2 and by 2px, 2py and 2pz 2. So we can write electronic configuration by first this one, then we can write the electronic configuration by orbital diagram, or we can write electronic configuration by inert gas in the inner core, helium, 2s2 and 2p6. So we can write electronic configuration of carbon either of these following ways. This is a very short configuration, helium, then 2s2 and 2p6, very short configuration. So okay, next we write the electronic configuration for nitrogen. Having atomic number 7, we write electronic configuration as 1s2, 2s2 and 2p3, or by orbital diagram we can write the electronic configuration as 1s2, 2s2 and 2px, 2py and 2pz, each one contributing 1 electron. So this is the electronic configuration of nitrogen. And for electronic configuration of phosphorus having atomic number 15, so it can write electronic configuration 1s2, 2s2, 2p6, 3s2 and 3p 10, 12, 3. So and we can write also the electronic configuration in orbital diagram, 1s2, 2s2, 2p6, then 3s2 and 3p3. So this is the electronic configuration of phosphorus. Or you can write electronic configuration in very short form using the inert gas up to this 2p6. We know that it is the configuration of neon gas, neon, then 3s2 and 3p3. So this is the electronic configuration of phosphorus in short form, neon, then 3s2 and 3p3. So here one important point that we need to know, the 2p6, here 2 is the energy level, p is orbital and a6 is the number of electron present in this orbital. So it is 2p6. Another important point is when you write electronic configuration by 1s2, 2s2 in this way, it has an advantage over only using 1s2, 2s2, because here all the all the quantum numbers are shown here. So it has an advantage over this one. It is orbital diagram and it is orbital notation, having an advantage in this process, having advantage where all 4 quantum numbers are clearly shown in this process. Here all 4 quantum numbers are not clearly shown, just we are writing the number of electron present in each orbital or subcells. Next important point is electronic configuration writing for ions. For ions, for example, if we want to write electronic configuration of sodium plus, sodium has actual atomic number is 11, and for sodium plus, where 1 electron is removing, the number of electron is now 10. So our electronic configuration is 1s2, 2s2 and 2p6. It is for cation. And for cation like Fe2 plus, Fe2 plus, actually the atomic number of iron is 26, and actual configuration of iron s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 4 1s, 2s, 2p, 3s, 3p, 4s, 3d6. Actually this is the configuration of iron: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. This is the configuration of iron, but we are seeing 2 electron is lost from iron, so our number of electron is now 24. So we minus the 4s subcell, 4s subcell from this electronic configuration, because electron is first removing from the 4s orbital compared to the 3d orbital. Electron first removed from the 4s orbital, not from the d orbital. So this is the correct electronic configuration of Fe2 plus. So now we can write electronic configuration of anion like Cl minus ion. For Cl minus ion we can write electronic configuration as 1s2, 2s2, 2p6, 3s2 and 3p6, because actual atomic number of chlorine is 17. 17 electron is present in chlorine, but here 1 plus is occurring because 1 minus, so total number of electron is 18 here, and 18 electrons are distributed as follows. We can also write the name as using short form neon gas, because we know that this is the electronic configuration of neon, and then 3s2, 3p6. So in this way we can write the electronic configuration of cation and anion. Another important point that is required to know, it is electronic configuration of half filled full filled concept, or you can say electronic configuration exceptional electronic configuration. So there are some also exceptions, some exceptions also in electronic configuration writing, as for example electronic configuration of copper. Electronic configuration of copper. Copper has atomic number 29. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. Here see 4s1, 3d10. Actually this is the electronic configuration of copper, which is an exceptional electronic configuration. It needs to be 4s2 and 3d9, but it does not occur because we are presenting the, if we are presenting the d orbital with orbital diagram, when 10 electrons are present, it is the orbital is fully filled, and half fill full fill electronic configuration in orbital, or half fill full fill electronic configuration of the subcell are very much stable, because it is half filled subcell. Sorry, this is not half filled, this is a full filled subcell. It is a fully filled subcell, so therefore 3d10 is the stable electronic configuration. It has high stability in the ground state. We have to know all the electronic configurations here we are discussing are in ground state electronic configuration. In ground state electronic configuration, this is an example of a very stable full field electronic configuration exceptionally. Another important example that is very important is for chromium. Cr, which has atomic number 24, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5. Here d5, 1 2 3 4 5. For the case of d5, each orbital contribute one electron, and it is called half filled half field electronic configuration, it is also very stable, highly stable, and for this reason here actually it needs to be 4s2 and 3d4, but actually it is wrong one, because d5 is a very high stable electronic configuration, highly stable. So therefore we write the electronic configuration in this way, not in this way. So these are the main important points that we keep in mind before writing electronic configuration. We have to follow the three principles: Aufbau principle, Hunds rule, and Paulies exclusion principle. During the spin electronic configuration writing with spin, you can write the all informations about the electronic configuration. It has advantage over the only orbital using only orbital electronic configuration. So these are the main points that you need to keep in mind before writing electronic configuration or to write electronic configuration. I think you understand this topic well, and you can write your comment on the comment sections. If you have any problems or any opinion, then you can share it with me. Thank you.